Hello everyone, welcome to our discussion of section 1.6 where we will be talking about linear inequalities. And what we mean by linear inequalities are inequalities that involve variables to power 1. So if we have higher powers of a variable, say x squared, x cubed, those kinds of inequalities would be nonlinear. So we'll be dealing with inequalities where the variable has power 1. Okay, so we have here the four symbols that indicate inequalities. This symbol and this one, these two are called strict inequalities. So these two and that one, we will call these strict inequalities because they only indicate either a quantity is less than or greater than some other quantity. They cannot be equal to each other. So for example, if I write say A on this side and B on this side, A less than B, that means A is always less than B. It can never be equal to B. And if I write K greater than M, that means K is always greater than M, and it can never be equal to it. But over here, where we have the equality symbol right underneath the inequality, if I put A on this side and B on that side, that means that A can be either smaller than B or equal to it. Either way, it's acceptable. On this side, if I say K greater than or equal to M, that means K can be greater than M or it can be equal to it. And we always read these symbols the same way we read graphs, from left to right. So A less than B, K greater than M, A less than or equal to B, K greater than or equal to M. Now there are some rules and principles that govern the meaning or interpretation of an inequality. For example, here, the addition principle says that if you have an inequality and if you add any constant value, if you add or subtract, so plus or minus, of the same quantity to both sides, the inequality is preserved. So if you start with A less than B, and then you say A plus C, and then the same number added or subtracted to the other side, then it's still going to be A plus or minus C less than B plus or minus C. Okay, so this inequality is preserved. The left side, it's still going to be less than the right side. The same way works where you have A greater than B, then if you add or subtract the same quantity C, which we generally call C, to both sides, if you add and subtract that C to both sides, the inequality is still preserved. So the left side was greater than the right side. You still have the left side greater than the right side. Okay. The other principle or rule we have about inequalities is that what we call the multiplication principle. So what this principle says is that if you have an inequality of either kind, A less than B or A greater than B, and if C is some constant that is a positive constant. So this, when we say C greater than 0, this is just mathematical way of saying that C is a positive value. Okay, so C is positive. So this is saying it in English, this is saying it in mathematical terms. Then, when we multiply both sides of these inequalities by a positive constant, the inequality is preserved. So the left side was less than the right side. It's still, after we multiply both sides by a positive constant, the left side is still less than the right side. If we start with the left side greater than the right side and multiply both sides by a positive constant, then still the left side is going to remain the larger side than the right side. However, this is very, very important, so I'm going to box this with red ink here. This is where things change, right? So if we have an inequality of either kind, left side less than the right side, left side greater than the right side, either kind, if we multiply both sides by a negative value, so this is saying C less than 0 means C is negative. Okay, if that's the situation, we multiply both sides of either inequality by a negative value, then the direction of the inequality is going to change to the opposite. So if the left side was less than the right side, now after multiplying both sides by a negative value, we have the left side greater than the right side. So left side less than right side becomes left side greater than the right side. Okay, it switches direction. Why? Because we're multiplying both sides by a negative value. The same thing is true with if we have left side greater than the right side. So multiply both sides by a negative value, then the left side becomes the less than the right side. Okay, so the direction of the inequality changes to its opposite if we multiply both sides by a negative number. The same thing is true if we divide both sides by a negative number. So even though these general examples involve multiplication, if you multiply both sides, so it says it here, if we multiply or divide both sides of an inequality by a negative number, then the inequality sign is reversed. Okay, so this multiplying and dividing by a negative number changes the direction of the inequality to its opposite. Very, very important. Okay, so now a great proportion of the discussion in this section involves compound inequalities. So what are compound inequalities? Compound inequalities fall into three categories. You can see all three categories here. You can be given an inequality and then with the word and in between and then another inequality. If you have this kind of compound inequality, then the solution of this kind of compound inequality, so all of this, the solution of this is the overlapping region. So what does this mean? It means you're going to have to solve each pieces individually. This one individually, solve for x here, solve for x there, and then see where those two solutions overlap. That overlapping piece is the solution of the entire compound inequality. Okay, that's what that means. So if you have this kind of a compound inequality, then you solve for x, and the solution of the compound inequality is in between the numbers on either side. So here, the solution is in between the numbers or values on either side. On either side, after you solve for x. Okay? So that means here you solve for x at the same time. How do you solve for x? Solving means isolating the variable, right? We know that. So in order to solve for x here, we need to isolate it by itself, which means we need to get rid of the 5, we need to get rid of the 2. So we subtract all three sides by 5. We subtract 5 from all three sides, from this side, this side, this side. And then we divide all three sides by 2. This side, this side, this side by 2. And then x will be isolated after we do that. And whatever numbers we have on either side will be the interval over which the solution for this inequality exists. Okay, so how about this one? So the word and indicates overlapping region, that we're looking for the overlapping region. And the word or, it refers to the union, not overlapping region, but union of both solutions. So we find the individual solution for this inequality. We find the individual solution for this inequality. And then we take the union of both sides to indicate the solution of the entire compound inequality. So let's write that down. So all of this means that the solution is the union of the individual inequality solutions. Okay, that means exactly what I said earlier. Individually solve each inequality and then take the union of both solutions to find the solution of the entire inequality. Okay, so these are the three kinds of compound inequalities that we have. And we will look at each examples of each one. So let's start easy with this example. Before we begin solving these, I want to strongly encourage you guys to grab maybe 2-3 pages of scratch paper, write these examples down, and before you watch the rest of the video, pause the video, solve these examples on your own, and then when you're done, then come back to the video and compare your solution with mine. That way you develop a very strong understanding of how these methodologies work, because it's very, very important that you just don't copy my answers down, but you give your own mind the opportunity to think over these problems, generate your own solutions, and then compare them with what I have here. Okay, it's critical that you do that. It's 90% of all learning. Give your own mind the opportunity to solve the problem first, then compare your solution with somebody else's. Okay, so I'm assuming you've done that, and now you're back. So let's solve these. Okay, so to solve this inequality, we want to bring or isolate all the terms that have variables in them to one side and take all the constants to the other side. To do that, I will have 8x, right? 5x is on the right. When I move it to the left, it changes the algebraic sign, minus 5x, greater than or equal to negative 5, which is already on the right, and then I'm moving positive 1 to the right, from left to right, so it becomes negative. That's basically the same rule we had for solving equations, right? You can move things around the equality or inequality symbol if you remember that you must change the algebraic sign for any term that you're moving. So in this case, that's what happened. Okay, let's do the basic algebra then. Subtract 8x minus 5x is just positive 3x, greater than or equal to minus 6. And then we're solving for x, so we're isolating x. So we need to get rid of the 3. How do we do that? Divide both sides by 3. So when we do that, we end up with x greater than or equal to minus 2. So we've solved the inequality, but we haven't answered this question yet because it says solve and write the final answer using the interval notation. So the interval notation is as follows. According to this, any x value that is equal to -2 or larger is the solution of this inequality. So that would be bracket -2 comma infinity. And let me box that like this. Okay, so the bracket indicates that -2, that the number that is next to the bracket, is part of the solution of the inequality. Hence, it's included in this interval. The infinity side always gets the parenthesis. Why? Because infinity, by definition, cannot be reached. Okay. In this case, they're not asking us to graph the solution, but to get a better understanding of this, let's draw, for some of these, not for all of these examples, let's draw a picture. So if we draw the real number line, I decided to do that because I still have a little bit of blank space here. And so from -infinity to infinity, and this solution is -2. So let's say that's -1, and this is -2. And so the solution would be -2 included. So I'm going to put a bracket here pointing that direction. And then I'm going to use my thicker marker, if I can find it, it's right here. All of this region that I'm highlighting or thickening is the solution of that inequality. And that's a graphical representation of it. I suppose some of the homework examples ask you to show the solution using graphically, and that's what it would look like. Okay, so this one, the next one, and I hope this answer matched what you should have solved already before me, ahead of me. Okay, so this one, and again, I'm hoping you've already solved these two, and you're waiting to see my solution, which would be great if that's what is happening. So again, just like before, we want to collect all the variables on one side and all the constant values on the other side. So we have 5y, we have plus y, and then no more variables on this side. And I want to send this -5 to the right-hand side. So we do have -6y, another variable on that side. So I need to bring that to the left, right? So plus, let me use, since I put my inequality symbol too early, so plus, I'm moving -6y to the left, from right to the left, so it changes the algebraic sign to positive. And then we have no more variables to move to the left side, so less than or equal to. Now we have 2 and -8 already on the right side, so all we need to do is move the -5 to the other side. When we move it from left to right, it changes the algebraic sign from negative to positive. Okay, so we have, add these together, we get 5y plus 6y is 6y, 6y plus 6y is 12y. Less than or equal to 2 plus 5, 7, -8 is -1. And then y, we're solving for y, so we need to isolate y. 12 is preventing y from being isolated. How do we get rid of the 12? We divide both sides by 12. So -1 over 12. Okay? So we've solved the inequality, but we still haven't written our answer using the interval notation. So let's do that. This is anything equal to or less than -1 over 12. Okay, so this would be parenthesis -infinity, comma, -1 over 12, bracket. And I hope this answer matches what you have. We have a little bit of a blank space here. Let's use that to draw a graph of this solution. So we have -infinity to infinity, 0 in the middle of the real number line. So negative 1 would be, let's suppose that this is negative 1. Negative 1 over 12 is much larger than negative 1, so it would be, let's say, somewhere here, right? Somewhere here, negative 1 over 12. So this is saying anything less than or equal to that, so therefore we have a bracket pointing in that direction, and I didn't mean to cover that number, minus 1 over 12. And then I will thicken this portion of the real number line to indicate that the solution covers this region, like that. Okay, so that's a graphical way of showing our solution. So this is interval notation. Let me write it. So this would be the interval notation, which is what we're being asked to give. And this is the graphical solution. And this is the solution in inequality form. Okay, so this one. Now this expression involves fractions, doesn't it? And nobody likes to deal with fractions, but there is a very easy way of getting rid of the fractions, right? It will simplify the expression a lot if we could get rid of those fractions before solving this inequality. So before I talk about how this is done, let me, on a piece of scratch paper here, let me show you what I've seen a lot of people do, and I don't know where they learned this technique, but it's totally wrong. So people want to get rid of these fractions, but the way they do it is not correct. So they say, okay, I want to get rid of this fraction on the left, so I'm going to multiply minus 5 over 6x by 6, and then on this side, I want to get rid of the 3/4, so I'll multiply that by 4 to cancel with this 4, and then they say, okay, I'm going to get rid of this 8 over 3, so I'm going to multiply 8 over 3x by 3. If you do this, you have completely destroyed the inequality. You're not solving anything. You've completely destroyed the problem. Why is that? Because you have multiplied each term here by a different number. So that will completely change this problem altogether. So this is not right. This is not right. So you do not want to do this. The books don't explain it this way. I'm sure none of your teachers have ever shown it this way. So I don't know where any of you who do this have picked up this way, this solution. Please don't do this. This is completely wrong. So the idea that you want to get rid of the fractions is correct, but this is not the way to do it. So how are we supposed to get rid of the fractions then? Well, we must look for a single digit, not multiple digits, by which we can multiply both sides of this inequality to clear all fractions at once, at the same time. That's the way to do it, not individually, but we need to look for a single digit such that if we multiply both sides of this inequality by that number, that single number could clear all these fractions at once. So what do you think that number is? Think about it. What single digit we can use to multiply both sides by to clear all these three fractions at once? Can you think of a number? It would be 12, right? Are there other numbers that can accomplish the same thing? Absolutely. Any multiples of 12 would do it. So 24 would do it, 36 would do it, 48 would do it, all those numbers. But why 12? Why should we use 12? Because 12 is the smallest number by which we can accomplish this goal, our goal of clearing these fractions. It makes the solution more efficient and easier. So let's do that. So I'll do it at least once because I don't want you to forget it. So let me write that down. Multiply both sides of the inequality by a single digit or single number that could clear all fractions at once. Okay? So that we decided that that was 12. So let's do that. So we're going to multiply the left side by 12. 12 times minus 5 over 6x. By the way, this is just, if you put the x after the fraction, it's the same thing as saying minus 5x over 6. So this x belongs to the numerator. Okay, minus 5 over 6x, and then less than or equal to, again 12, times 3 over 4 plus 8 over 3x, which means 8x over 3. Okay? Now, the other occasion where most people make a mistake here is that, so I have had students where they understand that they have to do this, multiply both sides by a single digit. But a lot of those students also make a mistake. Why? Because in the next step, they combine two things at once. They distribute the number and simplify at the same time. This causes a lot of errors. So I don't want you to do that. What I will need you to do is first distribute, then simplify. Don't combine those two steps. Okay, so that's wherever it's applicable. On this side, it's really not applicable because we have just one term here. So you can simplify. In here, you can simplify right away, but not on this side. On this side, on the right, we want to distribute first, then simplify. We're not going to combine the two steps at once. So, but on the left, we can. So 12 has factors 6 and 2, right? So 12, it can be written as 6 times 2. Then this 6 and this 6 cancel each other out. This one and this one cancel each other out. We're left with just 2. 2 times minus 5, minus 5x, it would be minus 10x. And that's on the left side. Minus 10x. Then on the right, that's where I want you to distribute first, but do not simplify until later. So we have, to keep my own word, I'm going to distribute first. 12 times 3 over 4 plus 12 times 8 over 3x. Right? Okay, so we distributed. Now let's simplify. On the left side, we're okay. So we're just going to write that down. On the right, so 12 has factors 4 times 3, right? So this 4, and this 4 cancel each other out. We are left with 3. 3 times 3 is 9. So 9 here. And then 12, once again, it's the same way, right? So we have 12 is 4 times 3. 3 and 3 cancel each other out. We're left with 4. 4 times 8 is 32x. So we have plus, that plus, or this plus, and 32x. Okay, so now let's move all the variables to one side. So we have negative 10x minus 32x less than or equal to 9, right? We're moving all the variable terms to one side and keep all the constants on one side. Okay, so we have negative 42x here, less than or equal to 9. And then we're solving for x, which means we need to isolate x. X is not isolated as long as it's got this minus 42 next to it. So let's divide both sides by minus 42 to isolate x. So in that case, we got to be very careful here. So let me write that. So be careful. You are dividing both sides by a negative number. Okay, so that means the inequality, as we learned on the first page, remember that? When we multiply or divide both sides of an inequality by a negative number, c being that negative number, whatever negative number, then the inequality changes direction or reverses itself. So if it was less than, it becomes greater than. If it was greater than, it becomes less than. Okay, it's that rule. So here we have x greater than or equal to minus 9 over 42. Okay, I meant to use my blue ink there. Okay, so we can simplify this, right? Because both 9 and 42 have 3 as a common factor. So that would be x greater than or equal to minus 3 over 14. Right? After you simplify, you get this. So we've solved the inequality here, but we need to put the answer using the interval notation. So we write down with a bracket, which indicates that negative 3 over 14 itself is part of the solution. And then, so the x value can be anything equal to or larger than this. So comma, positive infinity, and of course parenthesis always next to the infinity or negative infinity. So that is our solution for this, this problem. Okay. All right. So let's move to the next example. So again, here I'm strongly encouraging you guys to write this down on a piece of scratch paper, solve it, and then come back to the video. So I would strongly encourage you to pause the video at this point. All right, so the first thing we want to do is move everything to one side, and I'm assuming you've already solved this on your own. So let's move everything to one side and set the other side equal to 0. So x plus 1 times x plus 2 minus, we're moving all this term to the left, minus x times x plus 1 greater than 0. So why did we do that? Well, remember in these few examples that we did, in every case, we moved the variables to one side and the constants to the other, right? That's what we did. So here, all terms have variable in them. So we want to move them all to one side because they all involve variable. The other side, for now, it's equal to 0, which is the only constant left. Okay, so we move all the variable terms, and of course we have to simplify and until we get the final answer. But that's the reason we moved everything to one side, because all these terms have variables in them. All right, so let's simplify. Here we have, if you notice that we have x plus 1, x plus 1. So we can factor x plus 1 out. So let's do that. So factoring x plus 1. So I have x plus 1 then times x plus 2, right? X plus 2. Factoring, remember that it's the opposite of the distributive property. So that's how you can test whether what you factor is correct or not. After we're done, you can redistribute this into the terms on the inside of this bracket and see if you get the old expression back. If you do, then the factoring has been done properly. Okay, so x plus 1 times x plus 2, we're going to get this back, so it's fine. So what do we need to put here in order to multiply by x plus 1 to get minus x times x plus 1? Well, the only thing that we can have is minus x, right? Okay, and the other side greater than 0. All right, so we can simplify. Like I said, if you have any questions about how this factoring took place, just redistribute this into the bracket and you should get this old expression back. Because the distributive property and factoring are the opposite of each other. Okay, and of course, if you have any questions after that, please let me know. Okay, so let's simplify the inside of this bracket. We can do that, right? Simply let's move the parentheses here. So we're going to end up with x plus 1 times x plus 2 minus x. We can do that. We can just simply remove the parentheses because this minus comes after the parentheses. If it was in the beginning, we would have to distribute or multiply the minus into the parentheses. If this minus was here, we would have to multiply it inside, minus x minus 2, but it comes after it. So we can just remove the parentheses. Okay? If the minus comes after the parentheses, it doesn't do anything to the terms inside the parentheses. Only if it's in front, it will change the algebraic sign of all those terms on the inside. And greater than 0. So now, of course, you see that this x minus x cancel each other out. So we end up with x plus 1 times 2, right? Greater than 0. In other words, we have, so let's distribute the 2. We have 2x plus 2 greater than 0. Now this is compare this inequality with that inequality. Much simpler, isn't it? And we accomplish this by how? By moving all the terms that have variables in them to one side, to the left, and then factoring and then simplifying things. Okay, so now let's solve for x. We know how to do that. We have a variable term and a constant term on one side. We can't do that. We can't have that. We have to have the constant on the opposite side, right? Because the goal of solving for x is always isolating x. So we need to do that. So 2x greater than negative 2, right? 2 was positive on the left. When I moved it to the right, it became negative. And now x has to be isolated. It's got a 2 next to it. So we're dividing both sides by positive 2. Because we're dividing both sides by a positive number, minus 2 divided by 2, the direction of the inequality does not change. It stays the same. So x greater than negative 1. Okay? Remember that this was a strict inequality, right? This was one of those two that we mentioned on the first page. That's a strict inequality. It means that the left can never be equal to the right, or can never be equal to the right. So in this case, x can never be equal to negative 1, right? How do we show that? Okay, we show that by using a parenthesis when we write down our interval notation. So parenthesis, -1, comma, infinity, and the infinity side always gets the parenthesis anyway. So this is our final solution for that. Let's do a graph for this, because we've shown the graph in these two graphs that we showed before, in these few graphs, in these two. The interval notation, or the answer, included the boundary number, -2 in this case and -1/12 in this case. That was part of the solution. But what do we do if the boundary number on this side is not part of the solution? Okay, let's draw a graph for that. Right? So if this is -1, we know that -1, x can never be equal to -1. This is a strict inequality. So to show that graphically, we want to put a hollow circle right there on top of -1. So anything greater than -1 can be the answer, so that one. So I'll just show the parentheses like that. And let me use my thicker marker here to thicken this graph like that. Okay, so that's our solution. Okay, so the next one, it's about finding the domain of these functions and write the answer using the interval notation. So for a square root is an even root, right? By that I mean, let me bring my scratch paper back here. So this radical expression, this number, the number that goes in here, is called the index. Okay? It's blank in this case. If it's blank, by mathematical convention, it means that it's a square root, which means that's the square root. Okay, which means that number is 2. If it's blank, it is 2. By mathematical convention, we do not write it. It's left blank. But it's an even root. So the index number can be other numbers, like say cube root. If it's anything else than 2, we have to write it. We have to show it. So that's an odd root. If it's 4, we have to show it. If it's 5, we have to show it. If it's 6, we have to show it. So this one, and that one, these are even roots. Okay, these are odd roots. The 3 and 5 are odd roots. 2, 4, and 6, these are even roots. I'm particularly focusing on this. Why? Because if you have an even root of any kind, 8th root, 10th root, 12th root of any kind, the inside of the radical expression cannot be negative. At least if you're not looking for a complex number. And in this case, we are not. Okay, we're not dealing with complex numbers here. So the condition, because this is an even root, this inside cannot be negative. So we must guarantee that the domain, as we look for the domain, that x, all values of x that we include in the domain, cannot cause this expression to be negative. So let's start with that condition. X plus 8 can be equal to or greater than 0. So it can be 0. It can be anything positive, greater than 0, but it cannot be negative. So that's our condition. This is the condition we must meet as we solve for x. Okay, so let's then solve for x here. X greater than or equal to minus 8, right? I'm just moving positive 8 to the other side. It changes the algebraic sign from positive to negative. Okay, so in this case then, this is the domain, which means anything equal to or larger than 8. So D, or domain, is bracket -8, comma, infinity. This is our domain. And it says write the answer using the interval notation, which we have that. So once again, this is our interval. Let me say this now because it's going to come up pretty soon. If this expression is by itself, then we can only say that, okay, it can be 0 and it can be something positive. But if this same expression happens as a denominator to some fraction, then it cannot be 0, right? If this expression, so let me bring back my scratch paper. If this expression happens to be the denominator of some fraction, like that, if it's that, then x plus 8 must be greater than 0. So we can't say it can be equal to 0 anymore, because this expression is part of a larger expression, which is a fraction, and it happens to be the denominator, so the denominator can never be 0. Okay, so it's not just what kind of domain square roots or even roots have, but where do these expressions happen? Do they happen by themselves like this? Or are they part of a larger expression? Are they part of a denominator? If they're part of the denominator, then you cannot say that inside can be equal to 0. You cannot say that. You must exclude 0 as a solution, which is, this is how you do it, by using a strict inequality, right? This is why strict inequalities are so useful. Okay, so that. All right, so then next one. We want to find the domain of this expression, which has a square root in it. It's an even root, so we know that the inside cannot be negative. The -4 is fine. The -4 is by itself. So the problem might happen here, which we need to guarantee that it does not, by defining the domain the proper way. So 2x plus 3 must be greater than or equal to 0. Okay, it must be 0 or something positive. So let's solve for x. 2x is greater than or equal to -3. Then we're solving for x, which means we need to isolate it. So 2 is preventing x from being isolated, so we need to get rid of this 2. How do we do that? We divide both sides by 2. So x greater than or equal to -3 divided by +2. Because we're dividing both sides by a positive number 2, the direction of the inequality is preserved. Okay, so x greater than or equal to that. So let's write down this answer using the interval notation, which would be bracket, right? Bracket means -3/2 is acceptable and part of the solution. So bracket -3/2, comma, infinity parenthesis, like that. Okay. All right. Next, this is an interesting one, right? Because it's a fraction. So the numerator, x can be anything, right? There are no restrictions on x here. It can be anything. So the domain in the numerator, let me take this step by step. So in the numerator, the domain for x is -infinity to infinity, right? X. Now, in the denominator, that's where the problem is. In the denominator, the domain is we got to be careful here because this is part of the fraction, part of the denominator. So we should say 8 minus x. We know it cannot be negative, right? So greater than 0. So that's for sure. We cannot. This is an even root. This is square root, which is an even root. So this inside cannot be anything negative. So that guarantees that. But can it be equal to 0? Should I put equality here, right? Should I say 8 minus x greater than or equal to 0. Can I say that? Absolutely not. Why? Why not? Because this square root of 8 minus x is part of the denominator, and the denominator cannot be 0. So therefore, we should keep this as a strict inequality like that. Okay? And let's solve for that. 8 is greater than minus x. Let's move it to the other side. It becomes positive, right? Or we can write it as x less than 8. These two are the same thing. It's just written differently. I prefer this way of writing the same expression. Why? Because the variable is on the left. And I have a habit of solving by putting the variables on the left. It's more, the books are written that way, and so I'm used to looking at expressions like that. But if you want to keep it that way, that's fine too. They mean the same exact thing. Okay, so we have the answer, but let's write it using the interval notation. So this is saying anything less than 8, right? Not including 8. So how do we show anything less than 8 and not including 8? So we say parenthesis, negative infinity, comma, 8. So what would you put here? Would you put a bracket? Would you put a bracket here? You should not, right? Because if you put a bracket, that means 8 can be a solution. But can it be a solution? If you plug in 8 here, you get a 0 in the denominator, and the whole expression is undefined. So we want to exclude 8 from the domain. So therefore, we put a parenthesis, which says 8 is not included, but anything less than 8 is included. So if you have, this is saying if you have 7.9999999 all the way many hundreds of thousands of nines after the decimal point, that number is part of the solution. It's part of the domain. Part of the domain. But 8 is not part of the domain. Like that. Okay. All right, so we talked about the 3 kinds of compound inequalities. On the screen, you have 2 of them. The screen looks a little bit, let me try to, it looks out of focus, at least from where I am. Let me try to focus this. Okay, that's better. Oops. Sometimes it goes out of focus on its own. Okay, so now I strongly encourage you to write these 2 down on a piece of scratch paper. So pause the video, write these down, solve them, and then come back to the video when you have the solution. Okay? All right, I'm assuming you've done that, and now you're back. So here we have the kind of compound inequality that was this one, right? This kind. We have this kind of compound inequality, and whenever we have that, the solution is in between the numbers on either side after you solve for x. So let's solve for x. Let's solve for x and see what numbers are on either side. So to solve for x, we need to get rid of the negative 4 because we need to isolate x. So that means we need to add 4 to all 3 sides. Right? So 4 plus minus 1, we get 3. And 4 plus minus 4 is 0, so x plus 0 is x, which is what we wanted. We've now isolated x by itself. And 4 plus 7 is 11. Okay? So, but be careful here because these 2 are strict inequalities. That means x is any value between 3 and 11, but not including 3 and 11. So how do we show that using the, so they say, solve this, write the solution using the interval notation, then graph the solution set. So we need to do all of that. Okay, using the interval notation, how do we show that 3 and 11 are not included? Well, we use the parenthesis, right? If you put bracket, that means 3 is part of the solution, but these are strict inequalities. That means these numbers are not part of the solution. So parenthesis 3, comma, 11, another parenthesis. So that's our interval notation. Now we have to draw a graph for this. So let's do that. So we have, let's put 3 and 11. Let me say, suppose this is 3 and this is 11, right? Let's just suppose. 3 and 11 are not included, so I'm going to put a hollow circle on 3 and a hollow circle on top of 11, and then anything in between is the solution. And let me use my thicker marker for that. So anything in between 3 and 11 is the solution, but 3 and 11 themselves are not part of the solution. I hope this matches what you have after you solved it on your own. So this one, same way, right? This is the same kind of compound inequality. We need to isolate x, and then whatever numbers we have on either side, x would vary from one to the next. But compare this with that. These were strict inequalities, right? These are not. So once we've solved for x, the numbers on either side are part of the solution because of this equality under that. Okay, so the first thing we would do to isolate x is just get rid of this 1. How do we do that? We subtract 1 from all sides. So minus 1, minus 1, minus 1, right? Minus 3 minus 1, minus 4. In the middle, minus 1 plus 1, 0. 5x plus 0 is 5x. Less than or equal to 3 minus 1, positive 2. Are we done? No, right? X hasn't been isolated yet. It's got the 5 next to it. We need to get rid of the 5. How do we get rid of it? We divide by 5, all three sides. Why did we subtract and now we're dividing? Well, because 1 was being added to 5x. So we had to subtract it to get rid of it. But 5 is being multiplied by x, so we need to divide that expression and everything on either side by 5 to get rid of that 5. Okay? So minus 4 divided by 5, less than or equal to, we're dividing by a positive number, right? So the direction of the inequality stays the same because we're dividing by a positive 5. If we divided by negative 5, because this maybe was minus 5, then these would change. Both of these inequalities would change direction, but not in this case. So 5x divided by positive 5, less than or equal to 2 divided by 5. All right? So on the left, we have negative 4 over 5. We can't simplify this more than what it is. 5 and 5 cancel out. We get x less than or equal to 2 over 5, right? So we've solved the inequality, but they ask us to write this using the interval notation and graph it. So let's do that. We have equality this time. So how do we show that using interval notation? With bracket. So negative 4 bracket, negative 4 over 5, which means this number is part of the solution because it appears next to a bracket, comma, 2 over 5, and bracket again, because that's also inequality, like that, inequality combined with an equality. So this is the interval notation. Now let's graph this. So here's our real number line, negative infinity to infinity. 0 appears in the middle. So negative 4 over 5 is a little bit larger than negative 1, right? So if we have, let's say if we have negative 1 here, negative 4 over 5 would be somewhere here. Let's say here, negative 4 over 5, that one. And then 2 over 5 is a lot less than 1, right? So if we have 1 here, 2 over 5 is less than a half of that. So let's say this is 2 over 5. Okay, like that. So these numbers are included as part of the solution. So I'm going to show that with a full circle or a filled in circle. So I'm going to show that with this over 2 over 5 and this over negative 4 over 5 and anything in between, right? So all of that is part of the solution. So that's a graphical way of showing our solution. Okay? All right. Here we have, again, more examples. So please go ahead, write this down. Write this down and then solve this on your own. So pause the video. When you're done with your solution, come back to the video and see if your solution matches mine. Okay, so we have here fractions in this expression, and we need to get rid of this fraction, right? Both of them. Remember that we need to do this all at once. We can't multiply this side by some other number and this side by another number, right? So what number by which we can multiply both sides and get rid of both fractions at once? That would be 15, right? So let's do that. So we have 15 multiplied by the left side. We have 15 times 2 over 3. Multiplied by the middle. So 15 times all of that, let me put that in bracket, minus 4 over 5 times x minus 3, and then less than 15 times 1. Okay? All right. So now let's distribute and simplify wherever possible. And then on this side, on each side, left and right, it's already distributed form, so we can simplify immediately. Okay, so what do we have here? We know that 15 has factors 5 times 3, and 3 and 3 can cancel out, so we end up with 5 times 2, or 10. Right? Then less than or equal to 15. We can distribute we can simplify this by saying that, okay, 15 has factors 5 and 3. This 5 and that 5 cancel each other out. We're left with 3. 3 times minus 4 is minus 12. Right? So minus 12 after simplifying times x minus 3 less than 15 times 1 is 15. Okay, so we've now gotten rid of the fractions at once. So now let's distribute the negative 12 into this. So we have 10 less than or equal to minus 12x. Minus 12 times minus 3 is plus 36 less than 5. Notice that on this side we have inequality and equality, but on this side it's strict inequality. We got to be careful because this number, whatever it ends up to be at the end, it's going to be part of the solution, but not 15. 15 cannot be part of the solution. Okay? So now, in order to solve for x, we need to isolate x. So we need to get rid of this 36. We need to get rid of the negative 12. Okay, first let's get rid of the 36. 36 is being added, so to get rid of it, we need to subtract it from all sides. So minus 36 from this side, from the middle, and from the right-hand side. Okay, so we end up with minus 26, right? Minus 36 plus 10 is minus 26. Less than or equal to minus 12x, because the 36 and minus 36 add up to 0. Minus 12x plus 0 is itself. Less than minus 36 plus 15 is minus 21. Okay? All right, so now in the middle we have negative 12 right next to x. We can't have that because we're solving for x, right? So we need to get rid of this negative 12. How do we do that? We have to divide this time because negative 12 is being multiplied by x. So to get rid of it, we need to divide all sides by negative 12. So this side divided by negative 12, this side divided by negative 12, and this side divided by negative 12. We got to be very, very careful here because now these will change direction. These change. Let me change because we're dividing by a negative number, right? So on this side, we will have, let's do this step by step. We will have negative is positive. So we have 26 divided by 12. That'll change to opposite, greater than or equal to. These two divided is just they cancel each other. We have x. That one also changes. This one also changes to the opposite this way. Minus 21 over 12 is positive 21 over 12. Okay. Now we can simplify these numbers. So 26 and 12 have 2 as a common factor, right? So this 26 is 2 times 13, and 12 is 2 times 6, right? So the 2 and 12 cancel each other out. We're left with 13 over 6. So 13 over 6. And then 21 and 12, they have, 21 has factors 3 and 4, so 3 times 4. That's 21. 3 times 7. And 12 has factors 3 times 4. So the 3's cancel each other out. We end up with 7 divided by 4. 7 divided by 4. Okay? So we've solved for x, but this looks a little bit awkward. So because this is less than this side and greater than that side, and we always like to put the smaller number on the left and the larger number on the right. Okay, so let's just rewrite this. Okay, so we write x greater than 7 over 4 less than or equal to 13 over 6. This is just rewritten form of what you see above. Okay, just so that the smaller number is on the left, larger number is on the right. That's the only reason I rewrote it like this. But these two have the same interpretation. They're the same thing. Okay, so let's write the answer using the interval notation. Notice on this side we have strict inequalities, so that means 7 over 4 is not part of the solution. So 7 over 4 parenthesis next to it. Okay, that's how we show it using interval notation. But 13 over 6 is part of the solution, so 13 over 6 bracket. So this is our solution. And I guess they did ask us to graph these. So let me put the graph. I guess I have enough room here. So why don't I do that? Why don't I put the graph right underneath this here? Okay. So we have 0 here, and everything is positive. So notice the less than or equality translated into the bracket, right? 7 over 4 is a little bit over 2. So if we say and 13 and 7 over 4. 7 over 4 is smaller than 13 over 6, but let's show that with my calculator here. So let's just do a quick check with the decimal values, right? So 7 over 4 is 1.75, so less than 2. And then 13 divided by 6 is 2 point something. So 7 over 4, like that. So that's how we will put that. So to get a rough idea what those numbers are. So 1.75 would be, let's say if this is, if I put 1, well, I don't want to put the, no, let me just put, let me spread these a little more. So 1, 2, and then after that. So this is 1, that's 2. And then 1.75, which would be 7 over 4, would be somewhere here. Let's say here. And I'm going to put a hollow circle there because 7 over 4 is not part of the solution, 7 over 4. And then 13 over 6 is roughly 2.16 or 2.17. So it'll be right here, and that one is included in the solution. So I'm going to put a filled-in circle. Then I'm going to show, graphing this one was not quite easy because they're so close to each other, like that. Okay? So just notice the hollow circle on this side and the filled-in circle on that side, and that would be 13 over 6. Okay? All right. So the next one is another compound inequality of the OR kind. Let's look back at the first page where we talked about this. So if you have compound inequality of the OR kind, the final solution is the union of the individual inequality solutions. So we solved this piece by itself. We figured out what x is from this side. We figure out what x is for this inequality, and then we look at where the two solutions, the union, the final solution of the compound inequality is the combination of, or the union of this solution and that solution. It's the union of those two solutions, okay? So let's do that. So this one is pretty easily solved, right? All we have to do to solve for x is divide both sides by 2. So from here, we get x less than or equal to 4. And from here, we get x greater than or equal to 7, right? 10 minus 3 is 7. So this one, if we graph this, watch what or how the graph for this looks like. So we have this from negative infinity to infinity, 0 in the middle. So we have less than or equal to 4, right? That's, let's see. So if I say 1, 2, 3, 4, that's 4, 5, 6, 7, right? So one of these solutions, in this individual solution, it says 4 can, or x can be anything equal to 4 and anything less than that. So in other words, this one is saying this is the solution, that piece, right? That one says x should be greater than or equal to 7. So it says that's the solution, right? So they don't agree. Individual solutions do not agree with each other. You see that, right? But we have an OR. So that means the final solution of the compound inequality is this piece union that. So that would be negative infinity, that's that piece. negative infinity, comma 4, bracket, union, that's the OR piece. OR piece translates into that, union, bracket, 7, comma, infinity, parenthesis, like that. Okay? That's the final solution, the union of both individual solutions. I hope this matches what you had, what you have on your own scratch paper. All right. So here we have a compound inequality of the AND kind. Very important to notice these things, right? So let's look back at the first page where we talked about interpretation of these words. So if we have inequality and inequality type of a compound inequality, then the solution is the overlapping region. So that means we solve this individually, we solve this one individually, and the final solution is that wherever those two individual solutions overlap. What happens if they don't overlap? Then there is no solution. Why? Because we have this and that. So our final solution must satisfy both of those inequalities. And if we can't have an overlapping piece, then these two inequalities do not satisfy each other at any point, which means this compound inequality has no solution. So for this kind of compound inequality to have a solution, the individual solutions must overlap. Okay. So again, I hope that, go ahead, you can see two compound inequalities on the screen. Please write these down on a scratch paper. Solve them on your own. Write down the interval notation. Then unpause the video and see what I've done. Okay, if you do that, I think this video would be very, very productive in helping you learn how we solve these kinds of inequalities. All right, and I'm counting on you that you're doing this, okay? Because if you don't do it, I will not know, but I'm counting on you that you're doing this. All right, so I'm assuming you've done that and now you're back. So we're going to solve each one of these inequalities by itself. We have a variable term on this side. I'm going to keep that on this side. I'm going to move this constant to the other side with the other one. So 21, 1 is positive on the left. When I move it, it becomes negative. So minus 4x less than or equal to 20, right? We got to be very careful here because in order to solve for x now, what do I have to do? I have to divide by a negative number, which is negative 4, right? But that means this will have to change, right? We're dividing by a negative number, so this will change direction. So we'll have x on the left. This will change, become greater than or equal to, and on that side, we're going to have negative 5. Okay, so that's the solution for this side. So let's see what is the solution for this inequality. We have 5x greater than or equal to. Let's move this constant to the other side. It was positive on the left. When we move it, it becomes negative. Then 5x greater than or equal to 20, right? That's that. And then to isolate x, we have to divide by a positive number, 5, which means this does not change. So we have x greater than or equal to 4, positive 4, right? Okay, so let's, before we write down the interval notation, let's try to visualize what's happening here. So I'm going to draw a graph. Remember, this is an AND, so we need to look for overlapping region. Okay? So negative 5, let's say that would be 1, 2, negative 3, negative 4. Let's say that's negative 5. And let's say positive 4 is here. 1, 2, 3, 4. And both of those numbers are included, right? So I'm going to put a filled in circle here, and I'm going to put a filled in circle here. So what does this one say? This one says anything greater than or equal to -5. That means all of that. All of that is the solution. What about this one? This one says anything greater than or equal to 4, right? So this is saying that's the solution. All of that is the solution. But this one says, no, this is the solution. Anything greater than or equal to 4. So that way, that is the solution. Okay? But where do they overlap? Where do these individual solutions overlap? We want that because we have an n type of n compound inequality. This is where they overlap. Right? That's where they overlap. So because of that, the final solution, you can see it in graphical form here, but the final solution is bracket 4, comma, infinity, parenthesis. So that is our final solution. Okay? I hope this is becoming clear if it wasn't already. And I hope this matches what you have on your own paper. Like that. That's infinity. All right. So here's another one of those compound inequalities. This time, we got to be careful because this or means look for the union of solutions. So let's solve each of these individually. First of all, to get rid of this fraction, I'm going to multiply both sides by 2. So 2 times the left side, which is x minus 9, right? We're doing this to get rid of the fraction. 2 times minus 1 over 2. Then we have 2, let's distribute 2x minus 18 less than, this is a strict inequality, right? Less than 2 times minus 1/2 minus 1, right? 2 and 2 cancel out, we get minus 1. Okay, so let's move the negative 18 to the other side. We have 2x less than minus 1. If I move this to the right, this will change sign. So plus 18. Then we have 2x less than positive 17, or x less than 17 over 2, right? So we're dividing both sides by a positive 2, which means this strict inequality does not change direction. Okay, so this is one of the individual solutions. Let's look for the individual solution here. Once again, we want to multiply both sides by 2 to get rid of the one fraction we have. So 2 times x minus 9 greater than 2 times 1 over 2. Let's distribute now 2x minus 18 greater than 2 times 1/2 is 1. Okay, so let's move this negative 18 to the other side. When we do that, we change the algebraic sign, right? 2x greater than 1 plus 18, 2x greater than 19, right? So let's solve for x by dividing both sides by 2, 19 divided by 2. Okay, before we give the final solution, let's see it graphically. But this is not, the ORs are nice because it's the union of both solutions, right? So if they overlap, it's fine. If they don't, it's fine too. We can simply take the union of these. So we're going to have a solution. So, but let's look at the solution graphically. So we have this from negative infinity to infinity. 17 over 2, it's a little bit over 8, right? And 19 over 2 is a little bit over 9. So if we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 17 over 2, that's 8.5. Let me put a hollow circle there. And this is saying anything less than 17 over 2. So it cannot be equal to, the solution cannot include 17 over 2. Anything less than that. So it'll be all of this. Okay. And then we have 19 over 2. That'll be over, it would be 9.5, right? 19 over 2 would be 9.5. So if we have 10 here, say if that's 10, then 9.5 would be somewhere here. Somewhere here. And again, this is a strict inequality, so I'm going to put a hollow circle there. And anything greater than that is the solution. Like this. So we have 19 over 2. That's 19 over 2. And that's 17 over 2. Okay? So that's the solution. Wherever you see the thick lines, that's the solution for this compound inequality. But let's write it down using the interval notation. So for this piece, we say parenthesis negative infinity, comma, all the way to 17 over 2. 17 over 2 is not included, so parenthesis again. Then we had or, right? This or translates into the union of the other piece, which would be 19 over parenthesis, right? Parenthesis because 19 over 2 is not included, comma, infinity, all of that, right? Okay, so this is our final solution for this compound inequality. I hope this matches what you have on your own paper. Okay, so we have some, there's definitely context for inequalities. Okay, so what is the context? The context is when we have a word problem such that one side or the other has to be either at least that much, no more than that much, something like that. So we're looking for phrases that indicate inequality. So here, in this case, it says, looking for clues for inequality is for what years will the number of people collecting disability payments be more than, this is our clue to set up an inequality. That's the clue for that. Okay? So now let's read the problem. It says the equation this can be used to estimate the number of people. So y is the number of people. So this is number of people. Number of people in millions. Very important. So this unit is in millions. In millions. Collecting Social Security disability payments where X is the number of years after 2007. Okay? So if X is 2, we're talking about 2009. If X is 5, we're talking about 2012, and so on. For what years will the number of people collecting disability payments, when they say for what years, that means they're asking about X in this equation. Okay, because X represents the number of years. For what years will the number of people collecting disability payments be more than 12 million? So that number represents the number of people, which is equal to y. So let's set this up, 0.326x plus 7.1.48. For what values of x, or the number of years, these disability payments be more than 12 million. More than, because this represents the number of people. We were told that, right? We know that equation represents the number of people. Be more than 12 million. So should I put 12 and 6 zeros after that? No. Why not? Because we were already told that y is in millions. So all I have to say is just say 12. Because the units of this the units in the equation is in millions. So all of that, we're looking for the scenario where what x would have to be in order for the number of people collecting disability payments to be more than 12 million. Not equal to 12 million, but more than 12 million. Okay, so we set up the inequality like this. So this inequality is the interpretation of this problem statement or this context. And now we solve for x. So then we have let's move this to the other side. 0.326x greater than 12 minus 7.148. So let's calculate what that quantity is. So we have, let's see. Okay, like that. So 12 minus 7.148, and it's 4.852. Right? That's the correct. So this would be 0.326x greater than 4.852. Now we're solving for x, and 0.32x is preventing x from being isolated, so we need to divide both sides by this positive quantity, 0.326, 0.326. So these cancel out. We get x greater than. Let's find out what that quantity is. So 4.852, we want to divide that by 0.326. So we have 14, all of that, but we want to round that number, right? So let's round it to 14.88. Okay, x greater than 14.88. And because we're talking about years, let's round it to 15, to the nearest whole number. So round 14.88 to the nearest whole number. So this would be x greater than, so this would be about greater than 15. Okay? So x, remember, x represents the number of years after 2007, right? So let's add that to 2007. So let me move from here to there. So 2007 plus 15 equals 2022. Okay. So that's the answer. So after or beginning. So from here, so beginning in 2022 and afterwards, more than 12 million people will collect disability payments. Okay, so I hope this makes sense, and I hope you took the time to pause the video and to solve this before you saw my solution. Okay, so in the next problem, it says that Alex plans to invest $12,000, part at 4% simple interest and the rest at 6% simple interest. What is the most that he can invest at 4% and still be guaranteed at least $650 in interest per year? So the clue for us to set up an inequality is right here, the most. The most and at least. These two clues, the most, what is the most that he can invest here in order for him to be guaranteed at least this much. So these are, so that clue to the need for setting up an inequality to solve this problem. Okay? So in order to solve this, let's introduce variables. So here, in the previous example, even though we had a word problem, the variable was given to us, or were given to us, x and y, right? But in a lot of word problems, the variable is not given to you. So that means they're leaving it up to you to introduce and use variables. Let's do that. So the question is about what is the most that he can invest at 4%. So let's give that the variable. Okay, so let's call x. You can name any variable you like, such as x. X, let's take this as being the amount that earns 4% interest. Okay? And I'm sure your finance faculty or accounting or other faculty in business will talk to you about the difference between simple and compound interest. There's a significant difference there. But in this case, we just ignore that because it's not relevant to this problem. Okay, so let's take that as x, and it says partly this 12,000, part of it is invested in this account X, which earns interest at 4%, and the rest at 6% simple interest rate. So the rest, okay, so let's say, let's see. So the amount that earns at, and then the amount that is, so let's take the other amount as let's say y, right? The amount that takes, and the rest at 6%. Okay, this is, if we set up, well, let's set it up this way. So y as the amount that earns 6% interest, right? Let's start it that way because there are at least two different ways of starting this. So let's start it this way. I think you'll see in a minute why I chose y. And then what is the most that he can invest in this one, in x, and still be guaranteed at least that much in interest per year? Okay, so we're talking about interest now. Okay, so let's set up an inequality for the interest, at least that much interest. So we need to set up an inequality for interest. So where does the interest can come from? The interest can come from the account that has 4% in it. So that's 4% of whatever that amount, 0.04, right? So please remember how to convert decimals to, how to convert percentages to decimals and decimals to percentages. Very, very important for all business majors. So 4% is that much, but the interest would be 4% of that amount, 4% of X, right? So then plus, there's also interest coming from account Y, right? At how much? At 6%. So 0.06Y, and we want this interest coming from account X and account Y to be at least 650. So greater than or equal to 650. So let me make this clear that this is interest from X or account X and interest from Y, right? We want this interest from both accounts to be at least 650. But here there is a problem here because we have one inequality, two different variables. We're not going to be able to solve this like it is now, right? Two unknowns in one inequality. We can't solve it. But fortunately, they told us what was the total amount of the investment. It was $12,000. And we know that some of it, we took that as X, went into this account that earns 4%, and the rest of it went into 6%. Therefore, we know that Y, the account Y, must be 12,000 minus X, right? Whatever the amount that went into account X, subtracted from 12,000, that would be the rest of this amount that goes into account Y. So Y is equal to that. So we can replace Y in this inequality by its equivalent, and then we'll end up with one inequality with one variable. And then we can solve that. And that would be the variable that they're asking us about. What is the most that he can invest at 4%? So they're looking for X. Okay? Needless to say, if we know X, we know what Y is. So they're really knowing one leads to the knowing the other. Okay, so let's make the substitution. We have 0.04x plus 0.06 times y, but I'm going to replace it with the equivalent, 12,000 minus x, greater than or equal to 650. Okay, so let's distribute. We have, or let's simplify, 0.04x plus 0.06 times 12,000, it's 720. 0.06 times minus x, 0.06x, greater than or equal to 650. Okay? So now this is a linear inequality with variable terms and constants, and we know exactly how to solve this, right? So we have 0.04x minus 0.06x greater than or equal to 650 minus, let's move the 720 to the other side, right? Because it was positive, now it's negative. So subtract these two, what do we get? We get minus 0.02x greater than or equal to, subtract these two, we get minus 70. So x, we got to be careful here because we're going to divide both sides by a negative number, right? Minus 0.02, sorry, not x, but just minus 0.02, like that. And also minus 0.02 on this side. So what do we end up with after doing that? This will change, right? So this will, let me just point that out. Because we're dividing by negative number, this will have to change. And I'm running out of room there. So let me come up here. So we have x, change that to the less than or equal to negative 70 divided by negative 0.02. It's going to be a positive number. And that positive number, well, let's see on the calculator. Let me bring this into the screen. So 70 divided by 0.02, 3,500. So that would be x less than or equal to $3,500. So Alex has to invest either $3,500 or less in the account that earns interest at 4% in order to guarantee that collectively from both accounts he will end up with at least $650 of interest. So you might say, well, if he has the option of investing in an account that earns interest at 6%, why even bother to invest in the account that earns at 4%? Well, the thing in the real world, the higher the interest rate, the higher the risk. And because of that, people try to average their risk over accounts that have lesser interest, but they have lesser risk. And then part of their money, however much they decide they can afford, they put in the account that has higher risk, but it has higher interest or higher return. Okay, so that's that. So we can actually describe this. So let's put that. So Alex to invest no more than $3,500 in or at 4%. Okay, so that would be the interpretation of that. He can put 2,000, 1,500, 3,000, 3,500, but no more than 3,500. All right, I hope this matches the answer you had. We have another word problem here. So it says a foundation invests $150,000 at simple interest, part at 7% and partly at 7%, twice that amount at 4%, and the rest at 5.5%. What is the most that the foundation can invest at 4%? So again, this word, what is the most, that and this one, what is the most that the foundation can invest at 4% and be guaranteed at least that much in interest per year? So these are clue to the need for setting up, especially this one, setting up an inequality. Okay, that's the clue. These kinds of phrases, at least, no more than, up to, all of these are clues in a word problem that you need to set up and solve an inequality in order to answer the question. So because the question revolves about the account that yields 4% interest, right? What is the most that the foundation can invest at 4%? Let's give x that variable. So or that, let's assign that account the x variable. So x is the amount that earns 4% interest, right? Then what else they tell us? They say partly, that means part of that 150,000 lump sum money is invested at 7%, and then twice that amount at 4%. So we know that this x, whatever it is, it should be twice the amount invested at 7%, which means the amount invested at 7% must be half of x. So let's say 1/2 x. 1/2 x is equal to the amount that earns 7% interest, right? If you say this is twice that, is the same thing as saying this is half of that. So that's how I wrote it. And the rest at 5.5%. That means 150,000 minus x plus 1/2 x, or 3/2 x if you like to, but I'll just simplify it next. 150,000 minus that should be the amount invested at 5.5% interest. Okay? We need to do this. We need to write the amount invested in each account in terms of one variable. Otherwise, we won't be able to solve this problem. Okay? So unfortunately, the information they give us allows us to write all these amounts that went into different accounts, these three different accounts, in terms of the account that earns 4% interest. Fortunately, the way they word the problem allows us to do that. Okay, so now we want the interest from all of these three accounts. The one that earns interest at 4%, the one that earns interest at 7%, and the one that earns interest at 5.5%, to be at least that much. The interest from all these three accounts to be at least $7,575. So let's set up the inequality. So we have the interest from account X is 4%, right? So we have 0.04x, that's the interest from that account, plus interest from this account would be 0.07 times 1/2 x. That's the amount, that's how much interest it's going to earn. So that times that tells us how much interest in dollar terms. This is in percentage terms, but in dollar terms, that's how much interest that account is going to earn. Plus, of course, 5.5% or 0.055 times all of that, 150,000 minus x plus 1/2 x. And we want that, all of this interest from account X, interest from account Y, interest from account, or not account Y, but from the account that earns 7%, interest from the account that earns 5.5%, to be at least that much. So greater than or equal to 7,575. And I'm running out of room there. Okay. So this is the amount of interest earned from each of these three accounts. I hope it's making sense. If it doesn't, please let me know with your questions. Okay, so the next, we just simply need to simplify and solve this. So we end up with 0.04x plus, that's 0.5. 0.5 times 0.07, it's 0.035x. We can double check that on the calculator. So 1/2 is just 0.5, right? So 0.5 times 0.07, 0.035x, and then plus 0.055 times 150,000. Let's find out what that is. So 0.055 times 150,000. We have 8,250. I'm just distributing this 0.055 into everything here. And 8,250. This is simply 3/2, right? So this is 3/2x. So 0.055 times minus 3/2 x, right? So we have minus 0.055 times 3/2 x. That's just distributing this into that with the minus in front. And the other side, of course, is 7,575. Okay, so let's simplify this a little more. 0.04x plus 0.035x. So let's do this step by step. Like that. So 0.04 plus 0.035, 0.075x, right? So these two add up to 0.075x plus 8,250 minus 3/2 is 1.5. 1.5 times 0.055. 0.055, so let's do that. 1.5 times 0.055, 0.0825, right? So minus 0.0825x greater than or equal to 7,575. So let's add up all the two terms have x in them because we combine these two to that. And then we have this one, so we need to then this subtract that. Let's do that. 0.075, 0.075 minus that 0.0825. We have minus 0.0075. So minus 0.0075 x, right? And then let's move this 8,250 to the other side because it's a constant, right? That's how we solve inequalities. We keep the variable terms on one side, we combine the constants on the other side. So 7,575 minus 8,250. Oops, I went off the screen there, like that. All right, so minus 0.0075x greater than or equal to that number is minus 675. And then we divide both sides by, because we're solving for x, so we need to isolate x by getting rid of this term, this number. So we divide both sides by that number, that. So because we're dividing both sides by a negative number, let me remind you that this should change, right? This should change to the opposite, right? So on the left we have x, negative divided by negative is positive, and then this will change to the opposite direction, that way, and minus 607, and by the way, let's double check that. So 7,575 minus 8,250 minus 675 divided by that, 0.075, and of course that's negative. So we have 135,000. I think I did something wrong here, so let's double check that. So 675, this divided by that is positive. 675 divided by 0.0075. So we have 90,000. So x less than $90,000. So then this is saying Remember, X was the amount that earns 4% interest, right? So this is saying that the amount invested out of the 150,000, no more than 90,000 should be invested in account that earns 4%. So you could, the foundation can invest 60,000, 65,000, 80,000, or 20,000. But no, it should be less than or equal to 90,000. So because of that, then let's make that clear. So let's say that this is maximum or maximum amount invested in the 4% interest account. Anything less would be acceptable. 90,000 itself would be acceptable, but not anything more than 90,000. In order to guarantee the foundation at least this much interest in revenue. Okay, so we've come to the conclusion of this section. I hope this made things easier. If it didn't, if you have questions, please let me know. So I thank you for persisting through this video until the very end. And if you paused and solved on the problems before you saw my solutions, that's also fantastic. So for now, have a nice day, and I'll see you all again next time.